Hello everyone, welcome to our webinar today, Building Serverless Websites with Lambda at Edge. Our presenter today is George John, who's a product manager with Lambda at Edge. We'll be getting started shortly, but first we have a couple of housekeeping reminders. First, today's webinar is being recorded and we will be sending a follow-up email containing the on-demand links to the presentation deck and the webinar recording. Additionally, throughout the presentation, you will be able to submit questions to our presenter and moderators at any time using the Q&A window that you see on your screen. So make sure to engage with us and ask any questions you may have. We'll be having a live Q&A at the end of the webinar, so make sure to stay around and get your question answered. Without further ado, I'll turn it over to George. George, welcome. The floor is now yours.
Hello, everyone. Welcome to AWS webinar on building serverless websites with Lambda Edge. Thank you all for taking the time to join us today. My name is George John. I'm a product manager with the Lambda Edge team. So today, we're going to take a look at AWS Lambda and Amazon CloudFront, two services that are key to Lambda Edge. Then we'll do a deep dive into Lambda Edge. We'll take a look at some of its core functionalities, capabilities, and features. Then we'll see how you can build a serverless website at the edge. We'll discuss some of the most common functionalities that you would have to move to the edge, and we'll take a look at how you can implement that with Lambda at the edge. And finally, we'll make sure we reserve time to answer any and all questions you have for us. Let's take a look at the journey that got us to serverless computing. At the start, there was virtualization with virtual machines. With virtual machines, the abstraction was at the hardware level, and the unit of scale was a machine. Moving up the stack, you have containers. Containers abstract the operating system, and the unit of scale here is an application. So if you want to scale your application, you would have multiple containers with the application running parallelly. And then we have serverless. Serverless goes even further up the stack, where the abstraction now is at the language runtime. And the unit of scale is a function. So you could have multiple copies of the function running in parallelly for you to scale up. And AWS as a platform has an offering for each of these. We have an EC2 instance, which is a virtual machine offering. We have ECS, which is EC2 container service for containers. And we have AWS Lambda for serverless functions. As a customer, it is good that you have all these options to choose from. And when you would use depends upon how much customization and flexibility you want. So if you want to configure the underlying operating system, you want to select which operating system, whether it's a Windows machine, whether it's Linux. If you want to configure the storage, if you want to configure networking, if you want that level of detailed control, then EC2 instances, which are virtual machines, is a right option for you. If you want to move further up the stack, if you want a higher level of abstraction where you really want to focus just on the servers, you're managing, configuring the application of the servers and controlling scaling, then ECS is the right option. And then you have serverless. So if you want to control and run your code when it's needed, then AWS Lambda is the option available to you. We'll talk more about AWS Lambda here in a bit. AWS Lambda enables you to run code when you need it. And the side effect of that is that you pay only for the code or the compute time that you use. It is event-driven compute model. By that, I mean you can define an event or a trigger that would indicate when the function should execute. Today, AWS Lambda supports various triggers, one of which is S3. So for example, you can set up an Amazon S3 bucket, hook it up to a Lambda function specifying that whenever a put request is made to my bucket, I need to call my function. And Lambda takes care of scaling and running those functions on your behalf. DynamoDB is another endpoint. You can set up AWS Lambda to be the backend to synchronous API gateway endpoints. Now, we have seen customers using Lambda for various interesting use cases, one of which is performing real-time data processing. So instead of having a long, lengthy, complex Hadoop job doing batch processing, you could instead use Lambda functions to look at records that are being inserted to a Kinesis stream in real time. So essentially, you're moving away from a lengthy, complicated process to real-time processing with Kinesis and Lambda functions. We've also seen customers using Lambda for building scalable backend services, whether it's for a web or a mobile app. A lot of the customers who use AWS Lambda get started with using Lambda for gluing various disparate systems. So you could have multiple systems that are all glued. You can choreograph these different systems using AWS Lambda. So why use AWS Lambda to begin with? Now, the serverless piece might be obvious. There are no servers for you to manage. The setting up the host, the configuring of the operating system, the managing, monitoring, all that is abstracted away from you. You just specify the piece of code you want to run and specify when it should be run. The other benefit is more subtle, which is the continuous scaling aspect of it. You do not have to answer questions like, do I have enough capacity? Would I need more containers? Do I have enough capacity for the next 6 months? All that is taken care of for you by AWS Lambda when Lambda is the service that is invoking your functions. The third benefit here is not paying for idle or cold servers. AWS Lambda charges you only for the compute time and the requests you use on the platform. So all this is great. AWS Lambda is available in multiple AWS regions today, and you can choose the region you want. But Lambda is still confined to a single AWS region, and this works for a lot of the use cases. But we've also seen customers who have globally distributed application with users coming all over the world. That is when the edge, which is the part of which is from Lambda Edge, is going to help you with. So Lambda Edge enables you to run your Lambda functions in a global network of POPs or points of presence. Let's take a look at that in more detail. So Amazon CloudFront is a global CDN or a content distribution service from AWS. It was launched in November of 2008, so it's been around for close to 9 years. Over the years, we have built various capabilities and features to CloudFront. And we've also been constantly expanding our global infrastructure based on customer feedback. So recently, we announced 100 POP. That was a few days ago. Today, we have 101 POPs. Now, what is a POP? A POP is made up of two things. We have edge locations, and we have regional edge caches. So we have today 90 edge locations, which are data centers where CloudFront has presence today. And they're spread globally. They're globally distributed across the world. If you look at the map here, the small blue dots, where the blue and the purple indicates edge locations, and we have 90 edge locations today. And we are constantly adding on to the list. Some of the more densely populated areas have multiple edge locations, and hence you can see the purple dot on the map there. And the second concept here is regional edge caches. Today, we have 11 regional edge caches. Regional edge caches are mid-tier caches, so they sit between the edge locations and the origin. They are typically located in AWS regions, meaning that we have a lot more capacity available to us, which translate into better cache width for you as a customer of CloudFront. And today, we have 11 regional edge caches, and they're denoted by the orange circles in the map here. Now, this list would keep growing as we hear more from customers. We are constantly adding to the list by building new edge locations and regional edge caches. Customers typically understand the benefit of using a CDN for serving static content. The static content would be things like images, client-side, JavaScripts, CSS, that doesn't change or which is static. So the benefit of catching them closer to the end users and being able to serve back immediately is well understood by customers. But CloudFront over the years, we have built in various capabilities even for serving dynamic or accelerating dynamic content. We have made various network optimizations. We are leveraging AWS Backbone Network and various other changes and optimizations we have built in, all with the goal of accelerating dynamic content. Security is #1 priority for CloudFront. CloudFront has natively built in various security features, whether it's allowing you to terminate SSL TLS connections, integrations with Amazon Certificate Manager, supporting various Cypher suites. But in addition to all the built-in features, CloudFront also has integration with some of the other security-focused AWS services. For example, AWS Shield, which is a managed DDoS protection service, and AWS WAF, which is a web application firewall. AWS Shield standard feature comes out of the box to all CloudFront customers at no additional cost. You can use AWS WAF, which is the web application firewall, to define rules to filter the traffic that's coming in. And these rules are deployed in CloudFront Edge location, so you are able to intercept the request early on and take the action you want to. We looked at the global infrastructure, and we are constantly adding on to it, making CloudFront massively scalable. CloudFront, like all other AWS services, is a self-service platform. It's another drop-down available for you from the console if you would like to use the console. We also support API and CLI interface. There is no need for you to speak to our sales representative to get started. There is no commitment or minimum contract required. CloudFront is priced to minimize costs. It's an on-demand, pay-as-you-go prices model, and you pay only for the resources you consume. So putting it together, Lambda at the edge is really about running serverless applications on the edge. And the way you can do that is, for the serverless piece, you have AWS Lambda. And these AWS Lambda functions can now run in CloudFront Edge locations. And you have Lambda at the edge. Now, let's take a moment for a poll question. Can you all please take a moment to answer the question we have for you in front of your screen? Thank you all for taking the poll. Let's dive deep into Lambda at the edge. Lambda at the edge is an extension of AWS Lambda. So all the tool sets, the user experience, the features that are available to you through AWS Lambda is available also with Lambda at the edge. Lambda at the edge today supports standard Node.js programming environment. One of the key additional benefit you get with Lambda at the edge is that your Lambda functions are now not running just in one region, but when you use Lambda at the edge, the functions are replicated automatically and transparently across multiple AWS locations. So the no servers to manage, the continuous scaling, and never pay for idle, the benefits you get from AWS Lambda are also available with Lambda at the edge. But in addition to that, Lambda at the edge is globally distributed. So the functions you write are replicated to multiple AWS locations worldwide. Let's try to visualize that. For this scenario, let's assume that your origin is running in an AWS region in US, and you have users from across the world trying to access your content. So the user experience that a user trying to access the content from US would be different from somebody who is far off, like in Australia, for example, because the actual customization of the compute that is being executed runs at the origin server. Now let's introduce Lambda at the edge to the mix here. Lambda at the edge, like I mentioned before, replicates the Lambda functions that you order in North Virginia region automatically to multiple AWS locations worldwide. So going back to the scenario, when the user in Australia tries to access the content, CloudFront will automatically route the request to an AWS location that is local to that user. So in this example, it would be an edge location in Australia. And since your Lambda function is replicated worldwide, the function is now available at the location closer to the end user. This would translate to faster response time and lower latency for the end user. Let's zoom in on one of the CloudFront caches. So CloudFront cache has multiple edge locations like we have seen before. Let's take a look at one particular one. So on the left side, you have the end user who could be coming in from anywhere in the world. And on the right side, you have the origin, which is the definitive source of the data. Now, the origin could be in AWS, so it could be an S3 bucket, it could be a load balancer, it could be an EC2 instance, or it could be a server running in your own data center or colo. CloudFront really doesn't care where the origin is. We are agnostic to the origin location. Let's zoom into one particular CloudFront cache. Like we discussed before, CloudFront has multiple POPs throughout the world. So the user could be coming in from anywhere in the world, and the user is represented here in the diagram on the left side. And on the right side, you have an origin. So the origin could be in AWS, it could be an S3 bucket, it could be a load balancer, it could be an EC2 instance, or the origin could also be in your own data center or in your own colo. CloudFront is agnostic to where the origin is today. So let's take a look at what happens when the end user tries to access the content. CloudFront will automatically route the request to a CloudFront location that is closest to the user from a latency standpoint. Once the request lands at the cache, when it's a first request, it's going to be a cache miss. The data is not present in the location. And CloudFront will automatically fetch the data from the origin server, would serve the request back and cache the content. It caches the content so that when subsequent requests come from other users that lands in this particular CloudFront location, we can serve the request directly from the cache and avoid the unnecessary round trip to the origin, and the end user sees a faster response times. Going back to AWS Lambda is event-driven model. It's meaning that you need to specify the trigger or the event that would call the function you define. With Lambda at the edge, there are 4 trigger points or 4 points in the request response path where you can call your Lambda function. The first one is viewer request. So viewer request is right before the request lands in the cache or a cache lookup is performed. So if you want to do a computation or action right before a lookup is done, then the viewer request is the right point to do that. The next trigger for a Lambda at the edge function is an origin request. So origin request is triggered right before the request is sent out to the origin. The next one is origin response. Origin response is in the response path and right before the response from the origin is cached. And the fourth one here is viewer response. And this is triggered right before the response is sent back to the viewer. You should note that in the case of a cache miss, only the viewer, in the case of a cache hit, only the viewer request and viewer response comes into play. In the case of a cache miss, all the 4 trigger points are available for you to use. So Lambda at the edge events are all synchronous. So these happens in line with the request. Let's take a look at the request events. So the request events here in the diagram at the bottom are the green arrows. We have 2 request events, the viewer request and the origin request. So any modification you make, whether it's a change to the URI, whether it's change to the headers, cookies, is going to impact the object that's being requested. So if the changes are being performed at the viewer request, the object that is being requested from the CloudFront cache is modified. On the other hand, if the changes are made at the origin request, then the object that is fetched from the origin is going to be different from what is originally requested from the end user. Then you have the response events. These are events in the response path, namely the blue arrows here in the diagram. So you have viewer response and origin response. Any changes you make in the origin response is going to modify or impact the object or modify the object that's cached. and any change you make in the viewer response would modify the object that's served back to the end user. Lambda at the edge functions that you write gives you full access to the headers, the URIs, cookies, and query strings, essentially all the request and response properties. And these are available across all the 4 trigger points we discussed earlier. Lambda at the edge is unique in its capability to generate complete HTTP response directly at the edge, meaning that you do not have to make a call to the origin. You can generate a full HTTP response body directly from the edge location. And we'll talk more about it in a bit. Lambda at the edge is also unique in its capability to make network calls to external resources. Now, these resources can be HTTP endpoints, and they do not have to be in AWS. They can be in AWS. They could be resources like an S3 bucket. They could be a DynamoDB table, but they can also be outside of AWS. Today, network calls are supported in the origin-facing events, so origin requests and origin response supports that. We have another poll question now. Please take a moment to fill it out. Thank you for taking part in the poll. Now let's take a look at how to implement some of the core functionalities that are part of every website at the edge in a serverless fashion. First one that comes is response generation. If you have a website, the website has content, and you need to generate or create that content as part of the response. Lambda at the edge allows you to generate full static websites directly at the edge without the need to make a call to an origin. And it need not be static. It also supports dynamic websites. So due to Lambda at the edge's ability to make external network calls, you can actually make calls to multiple external resources. So these resources could be a S3 website, a S3 bucket for a template. It could be to a DynamoDB table. It could be to other data sources. Now, all these data can be collected and aggregated directly at the Lambda function, and you can build a dynamic web page there. It also allows you to generate customized error pages, and also gives you the ability to generate HTTP redirects. For example, if you find a user is not logged in, you can redirect to the user to a login page. Now, how can it do response generation? So going back to the 4 trigger points we discussed earlier, response generation can either be done at the viewer request or the origin request trigger. Now, when would you choose one over the other? Viewer request responses generated to the viewer requests are not cached. So if you have a use case where you do not want to cache the response, you can do it at viewer request. On the other hand, if you want to cache it, origin request is the right place to do that. And in your Lambda function, since you can make network calls to external services, you can call multiple data points, multiple HTTP endpoints. These could be AWS services. It could be other remote APIs. You could collect and aggregate all the content and then build a full dynamic web page directly at the edge and serve it back to the users. Another common functionality that you would need to move to the edge to build a serverless website is authorization of the users. Lambda at the edge gives you access to the request properties, including cookies or headers. Another use case where this would be helpful is, let's say you have users who could either be using your service for free, or there could be other users who are have access to premium content because they are paying or subscribing to your service. So what you could do is you could write a Lambda function which is triggered at viewer request. And what that Lambda function does is that when a request arrives, it takes a look at either the cookie or a header, gets the authorization credential, and you could have the code to authorize that particular user directly from the Lambda at the function. If you say that the user is authorized, you can allow the request to continue so that the requested object can be served back to the end user. Or if you find that the user is not authenticated, what you can do is you could either rewrite the URI so that you send the request to login page, or issue a redirect or a 403 access denied back to the user. You can also use Lambda at the edge for enforcing timed access to content at the edge. For example, you can make a call to an external authentication server with a user session to validate if the user request is valid or not. Let's take a look at how you can do that with Lambda at the edge. So in this particular scenario, the trigger point would be an origin request. Your Lambda function can take a look at the cookie. So it can read the value of the cookie to fetch the user session details. It can make a call to an external service. It could be authentication service that's external to the Lambda function. And the external service can then say whether the user is allowed to access the content or not. If the user has a valid session, you can allow the request to continue. If not, you serve either a login page asking the user to re-authenticate himself. A/B testing is another popular functionality that you might want to implement in your website running at the edge. So essentially, you can serve two different versions of your website without actually changing the URL which the end user is viewing. So how you could do that is by using the origin request trigger point. What you could do is when the request arrives for the first time, you check if the request has a particular cookie set. This cookie is an indication of which version, whether it's version A or version B of the website that needs to be served back to the user. When the request arrives the first time, the cookie is not set, you can decide to serve which version of your site you want to serve. It could be, the decision could be a simple flip of a coin, or you could have some logic running in your origin request Lambda function that makes a determination. Once you have determined that, set the cookie with the appropriate version, whether it's version A or B, and send the response back to the user. So the next time the user makes a request for the content, the request would already have the cookie set. You can inspect the cookie in the origin request and serve the appropriate value back to the user. This way, the user sees the same experience, is always directed to the same version of the website, and there is consistency as far as the end user experience goes. Another functionality that you can implement at the edge is personalization of site. You might want to serve a slightly different version of your website depending on the end user's screen size or device he's coming in from. So you might have a slightly more optimized version of your site when the user is coming from a mobile version as opposed to a desktop. Or you might want to do personalization based on the location the user is coming in from or the language preference the user has set up. How can you do that with Lambda at the edge? You can use a viewer request trigger for that. So your Lambda function at the viewer request can take a look at either the device type, which is available to you through the user agent header or through CloudFront device type headers. Or you could take a look at the location the user is coming in from through the CloudFront viewer country header, which is available for you in the Lambda function. And depending on the personalization you want to do, you can serve the appropriate relevant experience back to the user. So it could be a redirect to a mobile optimized version of the website or a redirect to a desktop optimized version of the website, depending on what device the user is coming in from. Another popular functionality that you might want to implement is the ability to rewrite URIs. Why you would want to rewrite the URIs could be due to various reasons. One reason is you probably don't want to expose your internal directory structure externally, or you probably want to give the same URI to all the users irrespective of user-specific properties. So a user coming in from a desktop or a mobile would still have the same external URI, even though behind the scenes the request is being served from two different locations. Okay, let's take a look at how you can do rewrite URIs with Lambda at the edge. So the trigger point for this scenario would be an origin request. And within the origin request, you can define the logic that's going to translate the URI scheme, which is seen by the end user, to the internal URI scheme. Another functionality that you might want to implement in your website at the edge is inserting security headers. These are some of the headers that you might want to add. And Lambda at the edge makes it very easy for you to do these header insertions without changing the application logic or without changing the origin. In this particular scenario, you can use the origin response trigger, and you can write a Lambda function which inserts the headers you want as part of the response flow. Let's quickly take a look at how you can get started on Lambda at the edge. I would suggest taking a look at aws.amazon.com/lambda/edge for more information and documentation on how you can get started on the platform. To quickly recap, we looked at the various functionalities of Lambda at the edge, its ability to generate responses directly at the edge, its ability to make network calls, the access you get to various request properties in Lambda at the edge functions. Lambda at the edge provides you the same user experience as AWS Lambda, so you can bring your own code. Lambda at the edge today supports standard Node.js programming environment. A key benefit of Lambda at the edge is that you can now run your code at multiple AWS global locations, meaning that your compute runs closer to the end user, meaning lower latency and faster response time for the users who are trying to access the content served through CloudFront. With that, let's take a moment to answer any questions you have.
Thanks, George, for a great presentation, and thanks to our moderators who have been answering customer questions. As mentioned, we will be transitioning over to a live Q&A now. We'll be back on in about 30 seconds. Back over to you, George.